Let's look at question 37, Sudoku solver. In that question, you give the 9 times 9 matrix. They already have some value in this matrix. You have to fill the rest blank box. After you finish, the whole matrix should be the Sudoku. What is Sudoku definition here? Each row you should use from 1 to 9 number. Only use this number one time. You cannot repeat. And each row, each column, and 9 small matrix will satisfy this requirement. So actually this question is similar with the question 36, same solution. So we use the backtrace to try possible value for each empty one and continue to try until we finish everything. We are done. Or if you try someone, for example, you try 2 in this box, try 1 in this box. Oh, find 1 is not impossible. So you change other value to try. So if you go to some box, you find you cannot continue. You can change it to any value, then that value will broken the row. So you have to go roll back. So this is typically backtrace algorithm. Okay, let us do that one. So we can give some roughly backtrace function. So this Berland backtrack function, right? And then we can do it. In here, personally, I dislike use char array. The input is this one. If it's dot, it means here is empty. You have to fill some other char from 1 to 9. So I like to convert this one to the integer matrix. Same matrix is only the numbers. It's still is the same size. Okay, and from the Y to the X, we do this convert. So it's a value. So if for char Y and X is daughter, we let it become the -1. Otherwise, will be the char minus char 0. Then we convert the char to the 1 to 9 int. So if for this one is -1, we can do something else. The numbers Y, X will be the value, right? And after we done, we call the backtrack. They can finish something. So this one they give you strings. It's very important. It's guarantee the input board have solution. So you can get some solution. So after that one, we copy code from this one to here. Actually, we just want a bold y, x, will be the number y, x plus chart 0. So this one will convert this one, and this is a void return value, and so they just change the input. So this one will, after done this one, we can bring the correct result back. Okay, so we already set up the initialized value, and let us implement the backtrace. So in that one, so in the beginning, we need to bring these numbers come in, right? And then we need to know which one is empty. So the -1 is empty. So we need to collect this empty location information. So but in this, for this purpose, we have empties. So array list, right? And if this is the -1, we collect we use the int array to save it, 2 element y and x. By this way, we know all the empty one, right? So here we know the empty list. And then in the beginning, we want to know the empty index, and we also want to know the total, how many we want to bring this one in. So actually you also can get its size, but the size will call some function, right? So actually for this reason, this is can save a little time. Okay, so if index is reached the end, we return true, right? This is the backtrace is written, everything is finished. Okay, otherwise we can continue to do it. So what is others? So we need to get a temporary will get from empties get empty index, and we know y and x. Okay, we get the y and x. We will, what is the next step? We want to know what is the possible value for it. So we want to get the possible value. So get all possible values. So we assume the possible value will save in the list of pos values, right? And then we try everyone. So we try, right? So if we try one, so try it. So then what we need to do is we call backtrace and empties and e index plus 1 and total, right, is next loop. Okay, if this one is true, so it means we find it, right? If we find it, the numbers y, x will become this value. This means we finally we find the result, we fill this one, and then return true. If we know this one, we get a result, we can return true. Otherwise, roll back. Okay, so right now we need to get our possible value, try, and roll back. We already built the framework, so we need to implement those things. So let's think this one. So yeah, we try to fill to y, x, and the value, right? And roll back y, x, and the value, right? And then here we'll get the possible value. How we can implement this one? So we can define some flag for each row, each column, and each small matrix. This flag we can call flag buffer or flag pool. They can tell you which value already used, right? So remember, we can use integer from 1 to 9, right? So for the each rows, so we have rows flag. Rows flag is enter. We have a 9 row, right? Each one we should have 10 because we have a number 1 to 9. Okay, we'll do the same thing. This is a flag. Okay, so this is a row, this is a columns, this is a small matrix. Okay, so, okay, SMS is okay. Now we need to fill them, right? So what's the function? Void fill y, x, and value. So for y, so for example, if we want here we want to fill some value, right? This one belongs to the row 0. So row his is y, and his value will become 1. So this means we set flag on it. So void rollback, exactly same thing. If we have a fill, we should have the rollback, right? And we do the columns x. Okay, Now we also need a small matrix. Here we need to give from the given y and x, find which matrix it belongs to. So we need to find a matrix index by y and x. This one I want to write a dirty but efficient code. So if y less 3, it belongs one situation. Else if y less 6, right? This is a y. So this one belong 1, this one belong 1, this one belong 1. 6 and else if, right? And then we copy this one, put here. Okay, change this one to x. Change this to x. Now, this one will return 0, return 1, return 2. So if y less than 3, they belong to these 3 matrices, and then we use x to decide which one. So do the same thing, copy, paste, and paste. So return 3, 4, 5, 6, 7, 8. So now by this function we can find the matrix index. So matrix index will be the small matrix y and x value to 1, right? Same thing to reset to 0. Okay, so here we fill it, right? We set the flag, and then we roll back. We also need to initialize this one, right? So where to initialize? Here. If it is equal to the -1, we do not need to do it, right? So if you wanted to initialize, also is use the rollback to set its value to 0. Oh, we do not need it because this is a flag. So we only need fill y, x value. So we set up initial value for those things. Now we need to implement find a possible value. So here, if any time when we calculate the possible value, if we create this object is not efficient, so I want to create for each one have we already provide this object, then we can directly use it. So how to do it is same thing here. We can set up this one to the. Actually, if we move this one to here, So we don't need this one, right, from here, and we don't need here. Then we will have the matrix, same thing, list buffer. This one will be the other list integer. So when the empty is added, so the buffer will add a new array list. Same thing. Now, possible value, we will from the list buffer dot get from index, right? And then if get possible for y, x, and p values equal 0, return false. Why we do that one? Because we want in here, if we do not get any possible value, because for some empty one, all the possible value is used by the row or column or small matrix, so we cannot have any one possible. So in that case, we directly return false. Okay. Okay, so same thing. We need to get a matrix index from this one. Okay, we get the matrix index, and then we for from I1 from 1 to I1 to 10, so 1 to 9, I1 plus. So if raw y, x, and I1, this is the flag, right, is equal to 0, and so it means we can use that value in this row. Same thing, column y, x, and I1 equal to 0. We can use in this column. And small matrix y. Oh, sorry about it. For row, we only use the y. And for column, we only use the x. And for small matrix, we use the matrix index I1 equal to 0. Okay, we can use that value. So now we have the return list integer return value. So return add I1. But before we do it, we need to do the clear. Then we return size. If we did not find any from 1 to 9 number can fill in that blank, so we return 0. If we return 0, we return false because we cannot continue. Let's roll back to try other value. Okay, let me see. This is a very complicated example. I cannot manually try this one. So let us submit the code and see it. So is something wrong here? Equal to this one. What is problem? Equal to here. Uh-oh. Line 14. Okay. So should be the bold. Okay, bold. Okay, try this one. Okay, for error 107. Okay, we should not use this one. Oh, which line has a problem? Oh, this is empty, so we need to give the initialize numbers. Then in the beginning is 0, empty size. So let me say size. Okay. Columns 35. Column is typo. Okay. Is other typo? 80 rows. Backtrack. Okay, typo here. Backtrack. Missing return. Okay. This one return false. Okay, and submit it. Yeah, I think we finished. So thank you for watching the video.